All right. Thanks. Good morning, everybody. Thanks for the previous speakers. So what I want to talk about today is a case study in using the carbon footprint to characterize and optimize a compute environment, right? A sort of making a compute environment hyperscale, but we're using kind of carbon as the lens through which to look at it, right? So I'm Erik Riedel. I lead a company called Flax Computing. I spent a number of years at IT Renew, where I get into the circular economy business, which is part of this. Before that, I spent many years at EMC and Dell and Seagate before, so kind of been building hyperscale systems for 25 years, and OCP systems for as long as they've existed, right? And so our premise, once we bring in kind of the circular economy, workload management, kind of design of systems, design of servers, storage, networking, et cetera, is that we could use the carbon footprint as a nice engineering metric to kind of all in all the components of what goes into analyzing a system, right? And of course, there's a lot more than carbon that goes into systems, right? So sometimes we burn carbon to make electricity. Sometimes we can just use the sun, right? Sometimes we have to mine minerals in order to make the electronics run and so on. And so I'm using carbon slightly loosely, right? So kind of the resources that go in is the footprint of what's done, right? But what's important is that that combined footprint, when you consider the energy that's being used to run the systems, the energy and the other resources that were used to build the systems, right, to manufacture, right, things that were used for transport and so on, then you have this all-in metric. And what we found in our experience, if you then reduce the carbon footprint writ large, then you also end up reducing the cost footprint, right? And then this is what's super important for customers, right? Because at the base, right, of our industry, right, is technology advances, right? New CPUs, new networks, new optics, new everything at higher gigabits, terabits, and so on, right? But what at least my customers for the last 20 years, right, when they're kind of rational actors or corporate actors, right, they have someone somewhere has a spreadsheet, and that spreadsheet is, well, what's the bottom line here, right? What am I getting in terms of the number of users my website can support, the number of computations my CFD can support, and so on? What's the end result workload from the all-in dollars? Right? And the most sophisticated of these customers, and then if you're not sophisticated, just use the cloud, and the cloud does the spreadsheets for you, right? But the most sophisticated customers consider the all-in costs, the hardware costs, the software costs, what you're paying your operations staff, the way that you're developing your systems, and so on. Even in many cases, they use the developers, right? How many developers do I need to work on the Linux kernel in order to get the best Linux kernel on my fleet of 10 million machines, right? And someone has to take that into account, right? So that's kind of what in the corporate world is referred to as that all-in TCO. Right? And so our contention is that if we use the carbon footprint, we can get an all-in technological metric for the system and the way we're running the system and so on. And then in parallel, we can let the finance guys do their money calculation. And it turns out that if you reduce the carbon footprint, you're also going to reduce their money footprint, right? In basically all cases. Right? All right, so let me get a little technical here, and before I go into the case study, right? So this is a slide that I've been showing for at least 5 years, if not longer, actually probably longer, of kind of the benefits of OCP, kind of from the early days, from the first 4 or 5 years, right? Was this idea of optimizing the server and the rack because you're going to do hyperscale computing. You're going to do rack scale computing, right? And so I do this, right? So we kind of do this comparison to traditional IT, if you will, right? So this is on the one side, kind of an OCP Leopard server. On the other side, a 1U pizza box from Dell. And those of us who have been kind of in the OCP community know this argument from early on, right? The idea was, okay, we're going to take the extra 2 inches, right? So that we're going to waste only 3 inches in a rack instead of 5 inches, right? And we also take these extra 4 millimeters in the open U versus a traditional U, but shh, don't tell about that. But what we get then as a result is we can now do 3 servers in 2U, where the competition can only do 2 servers, right? And when we do this in a positive way to promote OCP, we say, look at all this waste in this server, right? There's all this extra plastic, there's all these tiny fans, right? There's 12 tiny little fans in there, right? Why are there 12 fans? Because they need to be redundant. There's 6 groups of 2 fans, so that if one fails, it still runs the thing. Whereas in the OCP, there's only 2 fans per server instead of 12, right? They're 2U fans, so they're more energy efficient. There's less of them. They are easier to build, easier to manufacture. There's less materials, right? So the carbon footprint of those 2 fans in that server is significantly, right, maybe profound is too much, but significantly different than the 12 tiny little fans in that server. And there's umpteen different examples of this, right? There's different ways that the cards are wired and so on, right? So by optimizing and simplifying was one of the baselines of OCP, right? So now let's keep that in mind. So let's keep looking. But the other part that, okay, hyperscale approach. But the other part that that we've been discussing kind of with our customers for at least all the time that I worked at IT Renew and since then is one other aspect of the hyperscale approach, right? Is this 2-3 steps level of indirection, which is you need to simplify your IT. Right? That a lot of corporate IT, a lot of the environments that I worked with at EMC and Dell, but certainly at EMC, they'd have a dozen different storage systems, right? And 20, 30 different servers, right? All this complexity, all these things. The hyperscalers don't do that, right? And therefore, there's a lot of savings. There's savings in design, purchase, deployment, workload placement, and so on by using less SKUs. Right? So what does that mean in practice? So let's look at this environment. So we worked with a group at Boston University in Massachusetts, and they're running a kind of an internal cloud for some of their researchers, right? And this was their initial footprint when they first kind of engaged us, right? So almost a dozen different SKUs, a couple of different generations of technology, right? I have Sandy Bridge, Ivy Bridge, Haswell, Broadwell, Skylake class, and then what I've done here is quite a simplification, right? But there's for a 20-minute talk, I've characterized the total number of cores and the total amount of memory, right? So the existing footprint, they had 19 racks, 500. You guys are right about your HDMI. 1 second. Okay, 19 racks, 500 servers, just over 11,000 cores, 200 terabytes of memory, right? But all this complexity, so many SKUs, so many things, like the management overhead of this, they do it with grad students, I mean, they don't pay them very much, but it's still a lot of overhead, right? And so then if you focus on, kind of the most modern SKUs of that, it's kind of one view. But then our first approach was, okay, what if we bring them OCP, right? So if we bring them OCP, how do we do it? What's the most obvious thing to do, right? So the most obvious thing to do, we use our 2-socket kind of workhorse of OCP, 2-socket Tioga Pass server. And now if I want to match the same core count and roughly the same memory, I would configure roughly like this, right? So I'd end up with 280 Tioga Pass servers, give us just about 11,000 cores, just over 200 terabytes of memory. And then we also keep these other 2 SKUs. It's kind of a separate discussion. There are something that those servers can support that the other ones can't, or that the Tioga Pass can't. But so you keep 2 SKUs, so you end up reducing kind of a dozen SKUs down to 3 SKUs, and you get roughly the same total cores and the same total memory. Right? So this means if the workload is the number of VMs, or the number of user VMs, and so on that you're supporting, represented by these two metrics, the core count and the total memory count, you've gotten a massive reduction. Right? You've massively reduced the carbon footprint. You've also probably optimized the cost. Right? But wait. So it turns out it's not always a perfect answer because the technology is a little more complicated. And so it turned out that this particular team, they had also gotten a hardware donation from a large corporate customer. So they had several dozen pallets of additional servers from Dell. And those servers had a bit of a different design and therefore a bit of a different characteristic in the technology and in the way we calculate these footprints. So the server, one of the server models that they had, several hundred of in fact, was this something called the FC830 from Dell. It's a PowerEdge server, but it's a 4-socket server, right? And now, technologically, now I've got a 4-socket server in 1U, meaning in 2U, there are 8 sockets in their version, and I, in my fancy, amazed kind of OCP design, I only have 6 sockets. Right? In the memory, it's even worse. Right? Remember, they're running VMs, so memory footprint matters. They've got 96 DIMM slots in those 2U. They use 64 gig DIMMs, so this is 4 terabytes of memory in their same space. Right? The Tioga Pass a little bit disadvantaged on DIMMs, so I've only got 36 DIMMs. Right? There's another variant of this SKU, in fact. So the FC, these FC, is actually a product line called the FX. So it's a bit of a modular thing from Dell. And so there was another variant of that design where they can actually put in the same chassis 8 nodes of this something called the FC430, which is also a 2-socket server. All those are all the Dells are Broadwell class servers, but it's also a 2-socket server. So now they've got 16 sockets, 8 on the previous one, 16 here, 64 DIMMs, and we're still with 6 sockets and 36 DIMMs. So that means that from a carbon footprint perspective, in terms of how much I'm fitting into an existing space, right, this is a better solution, or certainly this is a better solution, right? And in the economic side of this, like when the corporation that originally bought these servers paid for this server, they paid through the nose for this 4-socket Broadwell server with 2 terabytes of memory and 64 gig DIMMs, right? But at this point, these are 4 years old, probably 3-4 years since they were bought. There was some depreciation that went on in the corporation, right? So from the point of view of the university, they were just as attractive as the servers that we would bring them from OCP recertified, right? And so what that ends up with is this analysis. So if they then keep both sets of all of the 430s and 830s that they have, then they would end up with 700 servers in 10 racks, but now they'd have, look, 33,000 cores, 600 terabytes of memory, and now our Tioga Passes start to look like maybe not the best solution. Right? In fact, if we just take it down to just using the 4-way machines, the 4-socket machines, you still end up with a significant, almost a factor of 2 in terms of core count, and more than a factor of 2 in memory count. And so that means from a workload basis, it just makes so much more sense for them to use these quad-socket, 64 gig DIMM, huge machines, because it's more than twice as many cores and more than twice as much memory, right? And so what we've done with them over the last several months, we've upgraded their networking to 25 gig. So those servers were 10 gig interfaces. We've upgraded them to 25 gig. We've upgraded the storage system. There's a whole other discussion about the storage. From they had a mix of HDD and Flash, upgraded it to all Flash, also drives that they already had. So we've recertified in that way. And as a result, the performance profile of this server is probably 5-6 times what it replaced, right? But most importantly for us, kind of from an engineering perspective, is that we've used the carbon footprint, the energy consumption, the sunk cost, the sunk carbon of having the hardware versus getting new hardware to get to the best all-in solution. Right? And then finally, just to make sure, we can't end on a, OCP isn't the solution to everyone's problems, right? There are some more creative options. So one of the things that we did when we were at IT Renew is we designed, prototyped something called the 1U Tioga Pass, where we basically shrunk down the heat sinks and dealt with the airflow in a different way, either with some type of rear door cooler or with smaller sets of fans, those evil small fans that I told you were a bad idea. But this allows us to double the density in a rack. The reason we did this is customers say, hey, we can do 25, 27 kW, 30 kW in a rack. How do we do this with your servers? We said, hey, put twice as many servers. And now I'm back in action, right? Because now I've got 12 sockets into 2U. They've got only 4 sockets, and we've got 72 DIMMs to their 96. So now we're back into a little bit pluses and minuses in terms of how well we're going to run the workload. Right? So I'm not going to go into kind of networking and storage because it's all the details. The final, I've talked about kind of extending life in the past, right? And so why don't I just move to the calls to action. So what we've motivated, so we can do the similar analysis also with the networking, similar analysis with the storage. We're talking about what workload benefit do you get for the carbon all in. The energy carbon that you're spending, the carbon that went into manufacturing the materials, and give some weight to material that you already have that's already been built versus newly manufactured. Right? So we have demonstrations of this out here in the OCP Experience Center. You can see how you would do a 1U Tioga Pass. We have deployments of this at the data center here in Stockton. Data center out in Holyoke is where we have kind of OCP deployments and Experience Center, as well as the BU system that we were just talking about. And we're working with multiple companies to characterize these carbon footprints. So reach out to us, send us information about your servers, send us questions about how you want to analyze the carbon, how you want to compare OCP to traditional, and engage the discussion on the footprint. So maybe I'll take one question and then turn it over to JM. I think JM is next. One question? John, thanks.
Thanks, Erik. Yeah, really good, Jim. Wanted to ask you about the first instance when you were talking about the height of the heat sinks. That was a problem, and I thought that was the way you could get more dense. But what about, we always talk about carbon. I mean, do you look at the other environmental impact categories? When you're talking about repurposing servers, like the resources, the material resources.
Yeah, so I think, so in our experience, right, we can fold that into the life cycle of the equipment, right? So the key is that a lot of people think about, the equipment lasts for 3 years because that's how finance depreciates it. But that's silly from an engineering perspective, right? The hardware is designed for 10, 12-year life, so what are we talking about the 3 years for? Then other places, it's like, well, the warranty's up after 5 years, so the hardware is worn out after 5 years. But that's not true either. Warranty is just a financial construct in who's taking the risk, right? And so when we consider, the life, so the way we look at it is we take each server and then the components in the server, think about it, what's the lifetime, right? And maybe it's 8 years, 10 years, 12 years, right? But whatever that logical lifetime is, and then amortize all of the resources across that lifetime. And so that means it gives a preference to a server that's being run 7, 8, 9 years versus a server that was developed last week, right? And if that server is developed last week, it's fine. As long as you use it for the next 8 years, you're good. Right? But that's the comparison, and then this carbon allows us to fold in basically all the resources, right? So we think we're considering and optimizing all that. Thanks, John. Thanks, everybody.
Sure.